So now let's get more deep into the LabView. So what I'm gonna do is that I'm gonna uh, create a program exactly like the one that we created in MATLAB for the tank. And as we move forward, I will show you like some tips and tricks with LabView and some like information, like initial introduction of LabView. Because I think this way you'll learn better than just giving you the tips. So I hope you guys all remember this problem that we had with the tank, that we are having a tank that the total volume of the tank was 20 liter, and initially we had 5 liter of water into the tank, and we have like a hose or something that is adding water to the tank with a flow rate of 2 liter per minute. And we want to know at different times whether this tank is going to get full or not, and if it's full, how much water is overflowed, and if it's not full, like how much more time we have left till we stop the hose, the tap. So let's get started. Open a new VI in LabView, and you will have two panels, the front panel and the block diagram. In the front panel, if you right click, it will open you to some set of controls. And among these controls, if you go to numeric, you will see that there is a tank option here. So if you choose a tank, you can see this hand here, and you can put it anywhere that you want. Just click, and then you have put the tank icon in your LabView program. And you can see it's both in the front panel and in the block diagram, because you have to like wire something to it so that it's running, right? It will run. And then you can see like you can play with the water level here, whatever you want it to be. In this specific problem, we are having a 20 liter of tank, so I can double click on it and change this to 20, and it's like an interactive mode, and it will change the number based on that. You can also make it bigger or smaller, like whatever way you feel it's going to look nicer. You can also change the name of it, but I like the name of tank for it, so I'm not going to change anything about it. So if you remember in this problem, we have some constant, like the total volume of the tank, 20 liter. This is a constant. This is something that the user types, and based on this constant, a program does a calculation and give you the display you the results and output. So yes, so total volume of a tank, the initial volume of water in the tank, which is like 5 liter here, and the flow rate. These are the constant. So we have to define these constants also in LabView, like we did in MATLAB. In MATLAB, we assigned a variable to it and said that the VT equals to 20 liter. So that was a constant that we assigned to MATLAB with a variable. Here it's also something like that, like we have to assign it with a control. So the name of the variable here is going to be a control. So, and control is something that a user controls. So if I right click in the controls, again, these are something in this window is something that the user can control. So that's why when you right click, it shows control here. And then if you go to numeric, there is a numeric control. This volume of the tank, flow rate, they are all scalar numbers, so they are numeric. So that's why I use a numeric control. So I'll choose that and then put it somewhere here, and I will type it, for example, initial volume of water in the tank. For some reason, my keyboard is not working properly, so I'll just type, yeah, I don't know what's wrong, but yeah. My keyboard is acting funny, like I cannot put an I in here. Initial volume of the water in the tank. I'm sure you can type like this is I'll just, yeah, I'm sure you can type in your program that the dimension of it is in liter. My keyboard is acting funny today. I'm not going to type the dimensions, but they are all in liter and minutes. So initial volume of the water in the tank. We have another numeric control, and that's the total volume of the tank. Yeah, parenthesis is not working for my keyboard, but it works. I promise that it works. Like, let's see if here it works. No, yeah, it's just my keyboard is acting funny, but it works. You can type it. So initial volume of a tank. So for example, here I know the initial volume of the water in tank is 5 liter and the total volume is 20 for that specific problem. So that's why this is a control, because you can type whatever number that you want it to be. So you can type that in here. And then we have another control, which is our flow rate. Flow. It is acting funny, like L. Oh my god. My keyboard is acting funny, you guys, sorry. Flow rate. It's acting funny. And it's 2 liter per minute. So these were the constant. So the other thing is these are the constants that you type as the initial value. And here in this problem also, the problem is asking you what happens after several minutes. So that minute is also something as a control that you give to the program, right? So you have to define another one, and you can call it time in minutes for sure. And for now, I'll just put 5 in here. So so these are some of the initial variables that you give to the program, so that the program can solve and give you results. So we know that flow rate multiplied time is going to give us a volume, and this is a volume of water gets into the tank, right? We cannot do anything else in here anymore. Now we have to go to the block diagram and do the programming here. So first thing we want to do is that we want to see the volume get into the tank. So it's flow rate times the time. So if you right click on the block diagram, you will have some function here. So these are functions, these are like mathematics stuff. So if you go to numeric, there's like plus, subtract, multiply. Here we want to choose multiply, and then choose multiply. So I'm going to show you something. Let's select this and then right click and go to help. For sure you know this is a multiply, but just to show you like what each of these things are, in case you choose a function that you don't know what it does, you can open the help, and in the help it will give you some example, and it says that basically if you wire 2 waveform values or 2 dynamic data type values to this function, and then some errors, this will do the multiplication. So it means that x multiplied to y is the result. So basically on the left side of your multiply function, you have the variables that you want to multiply them to each other, and on the right side you will have the result. So this will show you how this function works. So that's why we have to wire flow rate, which is like x, to time, which can be our y, and then the results is going to be the total, the volume got into the tank during this time. So if I then right click here and say create an indicator, so the flow rate and time were the controls, where a user controlled them and give them the variable. But the result of this multiplication is an indicator, because we control it by giving it some variables, but we want to see what is the result, and that's an indicator to the users. So we have to choose an indicator. So I want to show you several things here. So one thing, a control, there's always there's an arrow here, you can see. So there's always wire getting out of a control. On the other hand, for indicators, there are always wire getting in. So you can see that this triangle thing is in here. That means that it will receive a signal. So a control is something that a user gives a variable, the amount or whatever to it. So when we control it, we know the variable and we are sending the signal of that variable out. So that's why a wire is getting out of it, because we are giving the signal out. But an indicator is something that we do something and we just want to show it to the user that the multiplication of the flow rate to time is this much. So this is an indicator for a user, so the user can only see it, it cannot control it. That's why a signal always gets inside the indicator, because indicator only receives the signals and show it. So I will say it again. Controls send signals out, and indicator receives signals. So because this is a control, we send signals out, and we can play with the number of, if it's a scalar, we can play with it and give different numbers to it, and then do several like functions to it, mathematical functions to it, and then an indicator receives that signals and show it to the user. Note that here these signals, they are these signal wires, they are in orange color, and that means that they are scalar. They have some numbers in them. For example, if they are string, if they are like some text, they will be in pinkish color. But if there is a number, like a floating point number, it is always in an orange color. And also notice the thickness of it. This is like a one line, thin orange line, so it's not really thick. As it gets thicker, it means that it has different dimensions. For example, if there's a matrix or it's an array, a vector, it gets thicker and thicker. I will talk about it later, but for now, just notice that we are having an orange wire that is not thick. That means that it's only one scalar number. So flow rate times the time is going to give us volume. So I can change the name of it so I know what it is, and I will say volume of water get into the tank. Maybe it got into the tank. Oh my god, my keyboard is not working. Okay, so now you can see here we have this volume of water got into the tank. If you cannot find this indicator that you just defined here in the front panel, you can always select it and double click on it, and it will show you where it is in the front panel. This is also another thing that I want to show to you. Oh, one other thing. You can see like when I stand here, my cursor changed to like this icon, and this icon is like a wire icon. And if I click on here, this is a select, and you know, it's an interactive cursor. You can find this in here, I guess, maybe in view. Yeah, in view, tools palette, and you can see this shows up. If this is on, it means that this is interactive. Depending on where you stand, it will change, and it's actually the best thing that you can do. But if you only like turn this off and only do this, like now you cannot go to the wiring thing that you want. So you have to click on the wire and then select that wire and rewire things. So I'll suggest to make sure that this is on, so it's an interactive thing for you. If it is not on for you, just go to the view and then tools palette and make sure that this is on. So far we were able to give some controls to the program, and these are the constant that we know, input, and the time that is like the question thing that in our problem it will ask for us at different time what will happen to the tank. And we have defined the volume of water that got into the tank. And now we want to know at different times whether the tank has been overflowed or not. So now let's say that we still have this tank and these icons here that we haven't wired it to anything. So now let's go ahead and do that. So we know that we have some initial volume of water in the tank, and that initial volume of water in the tank is going to be added to whatever water that got into the tank with the flow rate that we defined, and that's going to give us the final volume of water that is in our tank. In order to have it like clean, I'm gonna select this and move it aside so this is closer to what I want to do. So it won't get cramped here. But notice that while I'm moving things here, inside here it's not moving, so they are not connected. That means that if I move this here, this will also move. It's just that when you wire them, they are important and they send signals to each other. If they are not wired, just moving them around is not going to change things. Like if I move the tanks around, you can see the tank here in the front panel is not changing. The position of it, it's there, it's input. But wiring is important. So basically, LabView, instead of you typing the code, you wire things together. And that wires send signals in and out. So we know that we have to add the initial volume of the water in the tank, which is the 5 liter, to whatever volume that we introduce into the tank. So again, you right click and go to numeric and choose this time add, right? And add is basically x plus y, the results on the right side. So y, the left sides are x and y right side is the x plus y. I'll give you several seconds to think. Why is not the other way? Yes, because x and y are the control. So we have to send them the signals. And then x plus y is the indicator. It's just going to show the results to the user. So that's why it's always on the left we have this and on the right is the results. And then initial volume of the water in the tank is a control. It's something that the user define it, which is 5. So I will send a signal of 5 to my add function, and I will send the signal of the volume of water that got into my tank to my y here as a control. So this here, so let me say it this way. The initial volume of the water in the tank, 5 liter, is a control. And we all know that the triangle is on the right side. It means that it's sending signal out because a user is defining it and sending signal out. But here I defined that the volume of water that got into the tank in this case was an indicator, right? Because it just calculates it based on the control and just show it to the user. And you can see here, it has a grayish color. It's not white like these things here. So whites, when the color is white, it means that it's a control and a user can define it. But when the color is grayish, it means that this is just an indicator and it will show the results to the user. So here we know that this is an indicator and the triangle is on the left side and it's only receiving signals, it's not sending signals out. But the value of this, which for example after 2 minutes with 2 liter per minute of flow rate is 4, the value of this 4 is still a value and can act as a control. Okay, so we can wire the here the y variable here, which is going to be added to the x variable. We can wire this to here, and whatever this indicator, whatever variable this indicator has, can be as a control for the next function. So, and then if I right click on here and then create an indicator again, because again I have to create an indicator, I cannot create a control. Let me show you why. Like if I right click here and say mistakenly I choose control, like see, I cannot wire them. You can see the error of the wire here, and you can see my running arrow is crushed. That means that there is some problem in my program. So I cannot do that because the results is sending a signal to a variable, and that variable has to be an indicator type of variable. It cannot be a control type variable. So I'll just delete this, and then you can always double click and click and delete the wires that are not nice. So I'll say right click here, sorry, right, you will stand here and then say right click, create an indicator, because there's a function happening here, the addition function happening here, and it needs to show the results, and the results are an indicator. But the value of the results can act as a control for another function. And I will name this as a current volume of water in the tank. I'm gonna move the tank here. So you have this, the current volume of water in the tank as a number, and if I double click, it's showing that this is here. But I want this volume to also be shown in my tank, right? So again, my tank here is an indicator. See that the triangle is on the left side, so it can only receive signals. It cannot send signals out. So I can wire this to this wire. I can put it anywhere that I want. I can put it here, I can put it in here, here, here. It doesn't matter. The length of a wire doesn't change anything. Anywhere in this wire, it's all whatever the current volume of water it is. It doesn't matter. It doesn't have any resistance or anything. So, and you can connect it to anywhere inside the water and inside this wire, and anywhere inside this wire you'll have these numbers. I will not do anything to this for now, because I just want to run this program that we have done so far and just show you like what is the water level and look at these numbers, and just gonna give you some idea like how this is working. So I'm gonna save it. You come to File, Save As, and I'm gonna save this problem. I'm just gonna save it in my desktop as a tank. And so now let's run it. So we as a user, we come and we define whatever numbers that we have in here. The initial volume of the water in the tank was 5, the total volume of the tank was 20, the flow rate was 20, and the question is what happens after 5 minutes. So this is not final yet. I just want to show you what it does. So now let's run it, and it will give us some results, which are the indicators here. So volume of the water that got into the tank, it says 10. So let's check. With the flow rate of 2 after 5 minutes, yeah, 10 is right. Current volume of the water in the tank is 5 plus 10, 15. That is right. And you can see here it's also showing 15 for us. So now let's try another thing, like 7. Notice how the water level jumped here. So we basically program it by we did a very simple basic programming here. What is the water level of the tank after several minutes, and that's it. So I want to show you some other things. You remember I told you that this highlighting execution is going to show you how this is happening. So let's go with 6 here, and now let's run it. So this highlighting is only on the block diagram, it's not on the front panel. So if I run it, you can see how these signals are sending, and the variables for each icons, it's all gonna show here. So now let's run. See 5 to 16. See what happened? I'm gonna do it one more time and then you can see. I'm not sure if I can make it in slow motion though, but I'll run it one more time. See signals, sending signals to there. So signal sends from different controls as a constant number, which was 5, 2, and 6. And they're doing the function, they're giving you the variables and then to the tank. So you can see like here in this variable, anywhere in this variable is 17. It doesn't matter, in this wire is 17. It doesn't matter where you put this wire to this wire. Anywhere that you connect this wire to this wire, they are all 17. It doesn't matter. And in LabView, you shouldn't only connect 2 things together. You can connect 2 things together, and in between you can have several wires that connect to that specific wire, because you have the results here and you want to do some other things with this result and have some other function running on that. So it should be doable. Like here, we have flow rate multiplied 2 times, and that gives us the volume of water that got into the tank. But this is our indicator, volume of water going into the tank. It has the grayish color here, it's not white like this one. But the number of the amount of this, which is 12, can act as a control for this adding function here. So that doesn't mean that this is only an indicator and you cannot do anything. The wire here, it transports a scalar number with itself. And that scalar number that is transporting in that signal, in that wire, can get out and act as another control for some additional function. So now let's say like we continue with this problem and we want to know after a certain amount of time if the tank is overflowed or not and how much it's been overflowed and the rest of the things that you already know. So to do that, I want to have a light that will turn on and turn off whenever the tank is full or not. So I will right click on a front panel. Why on the front panel? Because this is something that I want the user to see. So you can find these controls in the front panel. For programming and for functions, you can find the controls in the block diagram. You will get used to know when to go to the front panel and when to go to the block diagram, but just keep in mind whatever that you want the user to see, you can find it in the front panel. You can also find it in the block diagram, but it's easier that you go to the front panel. And whatever that you don't want the user to see, because it has a lot of programming and has a lot of functions, you can find it on the block diagram. So you right click on the front panel and you go to Boolean, and here we have a round LED, and then you can choose this round LED and you say that you can say that is the tank overflowed. Yeah, I cannot have that. So if it's true, it will be turned on, and if it's false, it will be off. So when you see the light on, that means that the tank is overflowed. So how can we do that? We have to say whether the volume of water in the tank is bigger than the total volume of the water or not. So I'm going to move this here so it's closer to my tank. And then here I'm going to right click, and then we are having a comparison function here. And I can choose the greater or equal. I'll go with the greater for now. And then I'll say greater. And again, that means is X more than Y? If X is larger than Y, it's going to be true. If X is not larger than Y, the result's going to be false. So our X is the current volume of water in the tank. So I'll just connect to the X. And our Y is the total volume of the tank. If you want to connect it the other way around, then you have to use the smaller comparison function here than the larger comparison function. Because I want to know whether the water in the tank, which is this one, is larger than the total volume of the tank. And you can see, let me move this here too. So this is my LED. So I will connect the results to my LED. So several things I want you to notice. You can see that the color of the wire here now is green. Why? Because when you ask, is X larger than Y? The answer is either true or false. So there are two types of answer. There are not a ton of answer like for the multiplication. You can have any numbers of the results, right? But for the comparison, the results can either be true or false. It can either be 0 or 1. It's just two things. And that's called a Boolean function. That Boolean functions are functions that the results of them are either true or false. And when you have a Boolean function that you are running, the color of your wire gets green. So whenever you see a green wire, that means you need a true or a false result. So what it does is that if X is larger than Y, the result's going to be true. And here in LabView, a true result for a LED light is a turned on light. It's a light green light. But a false result is turned off like this one. So now let's run it. Let's run it again. So I'll save it. You can always Control S and save it. And then, or you can come here and just click save. but see that our run icon is not crushed, so that means that we have successfully wired everything to whatever that it has to be wired. It might not be the perfect program. It doesn't mean that the program is perfectly built. It means that the program is not, it doesn't have any problem building it. So notice that the light bulb is on again. So, and I have the 6 minutes here, and the 6 minutes should give me 17 liter of the volume of water. So I'm gonna run it, and you can see that this is running, but this is stopped because it's still needed for that. And see that the false here appeared. Let me do it again. So it starts here. It will wait for this result to come in. It will show an F, which means false, and then the LED light bulb is off. So I will type 9 here, which I know it's gonna be overflowed, and I will run it again one more time. Just notice here this one, this wire here. T, which means true. The LED light is green. It's on, so it's been overflowed. So the volume of the water that got into the tank was 18 liter, and the current volume of the water in the tank is 23, which basically the tank is only 20, so basically 3 liter of it has been overflowed. So in the next video, I'm gonna continue showing to you, like, for different situation, how we can problem this. Like for our problem here, we had at different times what happened, and if the tank is overflowed, how much of water is overflowed. So we are gonna go with the if statement, and I'm gonna show you how to add the if statement here, that for different case, what happens. And we're gonna build up more on our program.